Hello student, I am Dr.A.K. Now I am going to start applications. Last class actually I have discussed first law of thermodynamics. Now I am going ahead. Applications. Many chemical reactions involve the generation of gases capable of doing mechanical work or the generation of heat. It is important for us to quantify these changes and relate them to the change in the internal energy. We know that internal energy is related to work done and also it is related to heat. Then this work done or heat must be correlated with internal energy. In that respect, we are discussing here. Okay, here in all now whatever I will continue, that will be based on first law of thermodynamics. In that only some change will be done, means correlation will be done. Delta is equal to Q plus W. Actually, here you should know delta U. Delta means always change. Okay, delta, del, all means change only. Even the differentiation D also. Then delta U is equal to Q plus W. That is the first law of thermodynamics. Sometimes it is written minus W also. If work is done on the system, means compression, then it is plus W. If work is done by the system, means expansion, then it will be minus W, because it is internal energy, it is losing. That's why minus W. Then both are correct. Delta U is equal to Q plus W as well as Q minus W. Q plus W means you are talking about compression and minus W means Q minus W. That you are talking about expansion. This you keep in mind. Okay. Now I am going to correlate with work. Work means we will put the here this work. I will correlate there with internal energy. We will derive some expression. Okay. Then that is related to work done. Now just you try to understand. First of all, let us concentrate on the nature of work a system can do. System can do work. Okay. System can do work, a system does work also. We will consider only mechanical work. Mechanical work means pressure volume work, means in that type of work where volume is going to be changed. When you will change the pressure, volume will change. Correct? Pressure volume work, that is called mechanical work. Mechanical work means always you should understand pressure volume work. For understanding pressure volume work, let us consider a cylinder which contains 1 mole of an ideal gas fitted with a frictionless piston. Frictionless, no friction. That type of piston which has no friction is called frictionless piston. Total volume of the gas, suppose it is the V1, and pressure of the gas inside is P. Again you listen, because only in the beginning you have to consider total volume of the gas, that is suppose it is a V1, okay, and pressure of the gas inside is P1, or initial also you can write initial also, from beginning initial and final and the end, like that way also consider. Meaning is same, either V1 you consider V1 V2 or P1 P2, same meaning. Okay, Then now consider total volume of the gas is V1 and pressure of the gas is P1. If external pressure PEX also you can tell, EX small EX means external pressure. Then because you are doing compression, you are applying pressure, hence obviously PX external pressure will be more than internal pressure. Okay. Then if external pressure PEX which is greater than P1 initial pressure, piston is moved inward. If you will apply external pressure, then piston will move inward till the pressure inside becomes equal to outside, means external. Let this change be achieved by a single step. Suppose directly you are pressed and compression took place. Let this change be achieved in a single step, and the final volume V2 you can write. V1 in the beginning now become V2. Okay, pressure become equal. Okay, during this compression, suppose piston moves a distance L. Okay, suppose we have pressed, then you can say during the compression, in the beginning volume was more, now we have compressed, then volume became less. Then suppose piston went inside L centimeter, distance L, small L you can consider. During the compression, suppose piston moves a distance L and its cross-sectional area of the piston is capital A. Area is A and distance moved is L, a small L. Okay, then now you can understand L is the distance and area, capital A is the area. Then volume, how much volume? Then you know that area into length, area into the distance, that is the volume, correct? That you know that area into length, that is equal to volume. Don't forget, area into length or distance you will multiply, then it will be volume. This is very, very important. Okay, this relation. Then volume change, how much volume change took place? Then this distance into area means L into A, that you can tell, this change you can tell, that is the delta V. Delta means change in volume, that is a delta V. Then L into A, that is called change in volume after applying the pressure. Okay, change in volume is LA, because gas went inside L distance down and cross sectional area of piston was A, that's why volume change is LA, means that is the volume, change in volume, delta V. Then delta V you can write V2 minus V1 or V final minus V initial, anything. Suppose you have written V final minus V initial, then delta V is equal to V final minus V initial, that is the change in volume, that you can write, that is equal to delta V, means delta V is equal to V final minus V initial. Again another relation you should know, or you might be knowing also. Pressure is equal to force divided by area. Force divided by area, that is equal to pressure. Force per unit area. You should remember always. All common relation you should keep in mind. It will help you everywhere. Okay, in solving the numericals or in deriving the expression or understanding the expression. Okay, small relation, important relation, common relation you should know. Okay, always keep in mind. Then pressure is equal to force divided by area, means force per unit area, that is called pressure. Here you will use this term, means P is equal to P, pressure means P, then P is equal to force divided by area, then force is equal to what? Pressure into area, pressure into area. Then here we can write force of the piston is equal to pressure into area, P into A, pressure into area. Now I am going to correlate. Then work done, W is the work done on the system, on that is means plus W. If W is the work done on the system by movement of piston, then again one more relation you should keep in mind. Work done is equal to force into distance. Force into distance, this is the third relation. Third relation I am talking about. Okay, that these things, W is equal to means work done is equal to force into distance. Don't forget. Okay, first I told you L into A, that is the length into area, that is the volume. Second relation I told you pressure is equal to force per unit area. And third, W is equal to means work done is equal to force into distance. Then now force relation already you have got from the relation pressure is equal to force by area, then force is equal to pressure into area. Okay, then that force you write here. Now force into distance, and force is equal to PA, force is equal to PA, and PA, P into area means force into area, that is the force. Pressure into area, sorry, force that is the pressure into area means P into A, that is the force, and distance is equal to L. Then W is equal to what? Work done is equal to pressure into area into L. Just you remember this again. These are the starting point of expression. We are going to derive expression, then this is the starting point. Work done is equal to force into distance, and force is equal to pressure into work done is equal to force into distance, and force is equal to pressure into area, and distance is equal to L. It means W is equal to pressure into area into L. L is distance. Then now again here I told you W is equal to pressure into area into L. Then area into L you can write delta V. Area into L you can write delta V means change in volume. Then work done is equal to pressure into change in volume. Work done is equal to pressure into change in volume, because A into L is the volume. Then volume change you have to write delta V. Here important things you have to understand. Here we are writing not only delta V, we are writing minus delta V. Minus delta V. Why minus? Then here you understand that work, compression work you are doing, that compression work, that is the plus W. Plus W. You have to bring the value, work done value in plus. Then how will bring this plus? Then here you are bound to write minus, because change in volume, that you can write in minus. Volume was more in the beginning, now piston you have pressed, it came down, then volume decreased, then volume decreased in volume, for that you can write minus delta V. Correct? Then 2 times minus you are writing. First as the volume decreased, for that purpose you have written minus delta V. But here one more minus you have written, because you have to convert this sign into plus sign, because work done has positive sign when you are doing compression. When you are compressing the gas, that time W will be positive. and when expansion, that time it will be negative. Then to bring positive sign, that's why you are writing minus term, minus, and again for the delta V, again minus delta V, then minus minus plus. Okay, keep in mind. Then you have written work done is equal to minus P into delta V, and again one more minus you are writing. For the delta V you are writing minus delta V. For the delta V you are writing minus delta V because volume decreased, and one minus in the beginning you have written. Then it became minus minus plus, means P into delta V, plus delta V means plus you have to not write simply because it is a multiplication sign. Then P into minus delta V now become P into plus delta V, means PV. Simply we can write work done is equal to P into delta V. This is the important point. Work done is equal to P into delta V. Now this expression is positive. In the beginning it was minus P delta V. Now due to the minus delta V, it became minus minus plus. Means work done is equal to P into delta V. Then delta V again you can write V final minus V initial. You can write. Then work done is equal to pressure into change into volume. Then change into volume, always you can think final minus initial. Anything, if change in pressure is there also, then you write same way. Delta P means P final minus P initial. You can write, both are equal. Then work done is equal to P into delta V, and delta V you know that is equal to V final minus V initial. Okay, or V2 minus V1, anything. Then now this I have told you, work done is equal to pressure into change volume, means P into delta V. Okay, this is the important relation for work done. Okay, now again you can, some concept I am telling you, that this work can be done, means pressure you are applying and change in volume is going on. Then work is going to be done on the system. Then now this work can be done in two ways, two situations are there. First, that external pressure you are slowly and slowly you are changing. Suppose from initial to final in 10 step, that change means delta V you have made change in 10 step. Then in each step there was a less volume change, means less work done. Then 10 steps were there. Then you add all step work done. Then that will be final work done. Final work done means you can write work done. That work done you can write simply summation sign you can write. Summation means sum. That is the minus P into delta V. Minus P into delta V you can write. Okay, because volume changed, only one negative sign you are writing. Okay, when it is required for compression and expansion, that time volume change minus V, minus delta V or plus delta V you will apply when you will think, when you are considering compression or expansion. Otherwise you write only minus P delta V. Minus P delta V. Delta V minus some position, that depends upon compression or expansion. Then one case I told you, then if it is work is going on step by step, slowly and slowly, then you add all work done, then final work done. Okay, this is called final work done, same work done, what you have considered in the beginning. Now second case, that if you will change the pressure, slowly and slowly, suppose pressure you are changing, correct, but external pressure is you can say little more. Actually you can understand like that, that in if the pressure is not, you can say, constant. Now we can think over pressure is, if suppose if the pressure is not constant, okay, in both cases what I told you, in two cases I told you, if the first case I told you, if the pressure is not constant at every stage of compression, then step by step you can, whatever work you have done, you have to add. Then you will get expression minus summation sin P into delta V. Now again, suppose pressure is constant. Okay, if the pressure is not constant, both cases not constant. If the pressure is not constant but change during the process, but change during the process, pressure change, actually it is not constant, it means pressure will change. Then suppose pressure change such that it always infinitesimally greater than the pressure of the gas. Then suppose pressure change very slowly, infinitesimally greater than the pressure of the gas. Inside gas pressure is less and external pressure is somewhat little more, that is called infinitesimally small. Suppose pressure was P, then inside pressure was C, then outside pressure, external pressure is P plus dP. dP means, D means differentiation, dP means very less change, very less. dP is very less, then P plus dP. Then inside pressure is P and outside pressure is P plus dP, little more, infinitesimally small. Then automatically you can say gas will go down, volume will decrease because of little more pressure is you are applying. Then work will be done this time also. Again second step, again little pressure you have increased, like that way only, dP. Then again little work will be done, like that way. If pressure is changing very infinitesimally, very less, like just like a P plus dP external, and down inside pressure is P, then that time volume will change, little volume will change. That also you can write dV differentiation, dV volume. Means if pressure you applied very less, then automatically volume change will be also very less. That is a dV. Which means when you applied little more pressure, dP, then volume has decreased very less. That is infinitesimally small, dV, change in volume, dV. Then when pressure you applied very less, then work has also been done very less. Work done is also less, means because volume change is also less. Then now this small volume change, now you can integrate. Now this is in so many steps this work can be done. Then little volume change will be there. Hence now integration you can do. Mathematics you can apply. Then in sign of integration, work done is equal to, now actually formula was there, W is equal to minus P into delta V. W is equal to minus P into delta V. That you know, already I discussed. Then same formula, only you are integrating because volume is going to be changed. Starting, suppose volume was initial and final volume was BF, or V1 V2 also you can write. Final volume V1, initial volume V1, V initial up to V final. Down you write initial, upside write final. Okay, sign of integration you have written V initial and maximum is final, V final. Then now you have integrated P into dV term. Minus is already there. Outside you can write out of integration. Then volume change from initial to final, means V initial, V final. Then now after what will happen, if you will do the integration, then what you will get? Actually two possibilities are there. Okay, that here just to think, I am telling you to change. Here P external means outside. P external at each step is equal to P plus dP in case of compression. In case of compression, P plus dP. In an expansion, what will happen when you are doing the expansion work? Then that P will be P minus dP, less. Then only expansion can take place. Only can when P plus dP, then compression will take place. When P minus dP minus, then expansion will take place. That time work done will be negative. Don't forget. Okay, that, and when this will be there, P plus dP, then compression will be there. That's why delta V value we have not written negative. Okay, only one minus we have written minus P into delta dV. Okay, because why, you don't know whether it is expansion or compression. Then that depends upon that situation condition, whether it is expansion or compression. Then if gas is compressed, then P plus dP, and if expansion is going on, then P minus dP. That's why together you can write P plus minus dP. P plus minus dP. Both you can, at a time you can write. Okay. Then this you can write in both way. P external may be P plus minus dP. Then now such process when pressure changes very, very small. That's why change, I am telling, it is not only increasing, it may decrease also. Pressure change means it is not always it will increase, it can decrease also. Hence this term is giving in idea for new term. Then P external may be P plus minus dP. Such process are called reversible process. What is the reversible process? Then when I can say P plus minus dP, P plus minus dP. Okay, both is possible. Hence plus minus together you can write. Then that is the situation for reversible process. This process is called reversible process. A process or change is said to be reversible if a change is brought out in such a way that the process could at any moment be reversed by an infinitesimal change. Reversed, maybe compressed, maybe expanded, means maybe backward, maybe forward. Okay, then that's why if a change is brought out in such a way the process could be at any moment be reversed by an infinitesimal change. Okay, a reversible process proceeds infinitesimally slowly by a series of equilibrium state. Okay, means reversible sign is given for equilibrium state. Continuously it is increasing, but always they are in equilibrium states. Means any time it can go back, can go front, go backward, go forward, backward, forward, means they can go in both ways. Then that situation when rate of forward reaction becomes equal to the rate of backward reaction, then that is called equilibrium position. Okay, then a reversible process proceeds infinitesimally slowly by a series of equilibrium states such that system and the surroundings are always in near equilibrium with each other, so system and surrounding. That's why this equilibrium will be maintained. Process other than reversible process are known as irreversible process. Second term, irreversible, not reversible. Irreversible means only in one direction. It is not coming back, only forward or only backward, not both. Then that situation is called only in one direction. Change is going on only in one direction. Monodirection, what we are telling, that situation is called irreversible process. In chemistry, we face problem that can be solved if we relate the work term to the internal pressure. We have to correlate. Already in the beginning I told you. Now we want to correlate this work to the internal energy. Then obviously a new term you will get after adding this work done with internal this work done to the internal pressure first to understand, then I will come to that. Okay, you have to correlate the work done term to the internal pressure of the system. Then what will happen? If we can relate work to the internal pressure I am talking about, work to the internal pressure of the system under reversible condition. Actually all things are same, already discussed. Only in case of reversible condition, that situation you are understanding. Only in case of reversible condition. Then same way, W is equal to, only in the place of W down you write reversible, REV, a small REV. REV means reversible. Then W reversible, W write, and down with the W, REV, a small letter you write. Then same things, equation is same. W reversible is equal to minus now again P into dV was there, na? Same thing, minus P into dV. Then now again same things, integration sign, V initial to V final. V initial in the beginning, V final upside, means V1 to V2 like that. Then minus sign of integration, V initial to V final, P into dV. Same things what I discussed. Then now here you have to add in the place of P. In the place of P means external pressure. Now you should write P plus minus dP. P plus minus dP. Okay, in the place of P external, you write now P plus minus dP in the place of P. Outside dV is there. Correct? Then now what will happen? That if you multiply dV with P also and with plus minus dP also, then it will become P into dV plus minus dP into dV. Correct? After multiplying with dV, because dV is outside, out of bracket, then if you multiply with both terms, then P into, it will become P into dV, means P external into dV plus minus dP into dV. Here dP into dV, this value is very, very, very less. Hence you can ignore this value. Then what will be remaining? Then it will remain only, you can say P into dV. Only P into dV will remain. Means work done is equal to minus sign of integration V initial and upside V final and P into dV. Only this term will remain. P into dV means P external here, P external into dV. That is the work done. Work done is equal to minus sign of integration V1 upon V2, or you can tell V initial, V final, P into dV. This actually, in real sense. Okay, one more step, then I will tell you. I wanted to tell you one thing, sir. But here, one more step is there. You are going to derive very, very important relation. Only one step is remaining, that you know actually. Now, actually, I told you work done is equal to sine of integration V1 to V2, upside V2, or V initial to V final. Then P into dV is there. Then now in the place of P, you have to put the value of P. And then how will you put the value of P? Then you know ideal gas equation, PV is equal to nRT. Ideal gas equation, PV is equal to nRT. PV. Then P is equal to what? nRT divided by V. PV is equal to nRT. Then P is equal to nRT divided by V. That value you put here in the place of P. Then you will get work done is equal to minus sine of integration V1 down, V2 up, nRT divided by dV upon V. That dV was there from the beginning. Then nRT upon V, in the place of P you have written, then it became nRT dV upon V. Okay, and if you sign of integration, now you are removing integration sign, now you are removing, then dV upon V, integration of dV upon V, that is equal to dV upon V is there, its integration will be only V. But here limit is there, V1 to, volume is changing from V1 to V2, hence maximum means final volume you write upside. Then ln V2 upon V1. ln V2 upon V1. This is the integration. ln, how did it come? ln means natural logarithm. How did it come? Then it came after integration. After integrating dV upon V, it turned to ln V2 upon V1. Then this ln now you can convert into log also, logarithm. Then now you got actually work done is equal to minus nRT ln V2 upon V1. You got minus nRT ln V2 upon V1. Now if you want to change ln to the logarithm, then you have to multiply it with 2.303. ln is equal to minus 2.303. Okay, then it will convert into log. Log is equal to minus 2.303 is equal to